guys, this video is going to go over the section 3 review. So question number 1. Notice that we are going to evaluate each of those given we have 3 different piecewise functions, f of x, g of x, and h of x. So number 1 is asking us to find what h of negative 3 is. So I'm going to be using the piecewise h of x. Now, since the x value is negative 3, I would fit that into which of these equations is that domain actually matching for. I'm using the first equation when x is less than negative 3. Negative 3 is not less than negative 3. I'm using the second equation when it's between negative 3 and 1, but not including negative 3. So that doesn't fit into there either. And I'm using the third one when x is greater than 1. Negative 3 is not greater than 1 either. So negative 3 is actually just not a part of the domain for h of x. So this would be does not exist with D and E because there is no point where on h where I will use the x value of negative 3. The next one is g of 1. So I'm going to be using the function g for this one. And I'm plugging in the x value of 1. Again, matching where does that 1 fall into place? Is 1 in between 2 and 4? No. Is 1 greater than or equal to 4? No. So this is another example of does not exist. 1 is not a part of the domain for the function g. So that point does not exist. Next, I have f of 0. So now I'm going to use the function f over here. And I'm going to plug in the x value of 0. So if I'm plugging in the x value of 0, I have to, again, figure out where does that fall into place. Is 0 less than 2? Yes, 0 is less than 2. So I'm going to be using this first equation here, plugging in 0 for x. So negative 0 squared plus 2, 0 squared is 0, negative 0 plus 2 is 2. My next one, I have f of 3. So I'm going to be using the same piecewise function, f of x, but this time I have a different x value that I'm plugging in. I'm plugging in 3. So the question is, does 3 fall into the first equation or the second equation? Well, 3 less than 2 is false. So is 3 greater than or equal to 2? Yes. So I'm going to be using the second one. 3 is greater than 2. So I'm going to be plugging in x here, which is going to be negative 3, and notice the negative 3 is in parentheses, squared plus 1. So negative 3 squared, that's 9. 9 plus 1 is 10. So part J is 10. Next, I have h of 0. So I'm going to go back to my function h over here, and I'm plugging in the x value of 0. So where does that fall in? Is 0 less than negative 3? No. Is 0 in between negative 3 and 1? Yes. So since 0 is between negative 3 and 1, I'm going to use the second equation, which just the y value is just 2. So the answer on part B is 2. Next, I have h of negative 5. So I'm plugging in x value of negative 5 into the function h. Is negative 5 less than negative 3? Yes. So I'm going to be using the first equation on this one, plugging in negative 5 would be 3 times negative 5 minus 1. 3 times negative 5 is negative 15. Negative 15 minus 1 is negative 16. Next, we have h of 1. So I'm plugging in x value 1. Is 1 less than negative 3? No. Is 1 in between negative 3 and 1? And notice we are including 1 because this x is less than or equal to 1. So that is true. So that would fall into this second equation. So I'm going to go ahead and plug in 1, but I mean there is no variable, so the y value is just 2. Next we have f of g of 4. So we have a little bit of composition here. Okay? So first I'm going to start with the inside part, and I'm going to find what is g of 4. So I'm plugging in x of 4 into the function g. So if I plug in 4, is 4 in between 2 and 4? Notice 4 is not included here. So I will use the second one. 4 greater than or equal to 4, that's true. So I'm going to use the second equation for g there. So I'm going to plug in 4, so it's going to be negative negative 4 minus 2, which is negative 6. So g of 4 gives us negative 6. So now when I plug into f, I'm plugging in that negative 6 that I just found from g. So I'm finding f of negative 6 now. Now, plugging in negative 6 into my function f, negative 6 falls into the first equation. Negative 6 is less than 2. So I'm going to be using the first equation on that one. So I'm going to use negative, plugging in x, is negative 6 squared plus 2. Negative 6 squared exponents first is positive 36. That negative 1 is multiplying in front, so that's a negative 36 plus 2 is negative 34. And that's part K. Next we have f of negative 3. So we're going to plug in x is negative 3 into the function f. Negative 3 less than 2. So I'm going to use the first equation on that one. So I'm plugging in negative 3 in for x. But that negative outside in front is not in parentheses with the x. You see the difference here? Okay, if it was in parentheses with the x, then we would be squaring with the negative in it. But it's outside. So we square that negative 3, which is 9, and then the negative is in front plus 1. It's a mistake here. It's plus 2, not plus 1. Plus 2 is going to give us negative 7. Okay? G of 1/3. Well, where does 1/3 fall into play? Is 1/3 in between 2 and 4? No. 1/3 is like 0.3 for heating, right? Is 1/3 greater than or equal to 4? No. So 1/3 is outside of the domain. That doesn't fall anywhere into the function g, so this does not exist. Alright, and then the last one, part I, h of 3. So I'm plugging in x value of 3. Is 3 less than negative 3? No. Is 3 in between negative 3 and 1? No. Is 3 greater than 1? Yes. So I'm going to plug in into the third equation. Negative 3, and then plugging in our x value, which happens to be 3, will give us a negative 9 answer on part A. Alright, next up we have number 2. So they want us to write the rule for each of the functions below. So we're going to go ahead and write the function rule. I'm going to label the first one just f of x. So this is 2 separate lines. So I'm going to go ahead and write the equation of both of those lines. For the first one here on the left, notice that we have the slope of rise 3, run 2. So the slope is 3 over 2. And then I need to figure out what is the y-intercept. Now, when I go up 3 and over to the right 2, it's going to fall somewhere in between here, somewhere around like 1, 2, 3, 4, like 4 something. But I don't know exactly what that number is. So one of the ways that I can actually determine the equation in slope-intercept form is by using the point-slope form. So I'm going to use this point right here, which is negative 3, 0, as my x1, y1. And so my slope, my point-slope form is y minus y1 equals the slope times x minus x1. Since x1 is negative, it'll be plus 3. I then distribute 3 over 2, which gives me 3 over 2x plus 9 over 2. And y minus 0 is just y. So the equation here is 3 over 2x plus 9 over 2. So it was 4.5. Now, when am I using that line? I'm using this line to the left of negative 1, when x is less than negative 1. Not including negative 1 because notice that is an open circle there. And then my second line is actually just a horizontal line on the y value of negative 1. So this solution is that the y value is always equal to negative 1 as long as the x value is more than or equal to negative 1. So we're using when x is negative 1 because it's closed here and to the right, and the y value is always negative 1 for that point. Okay, part C. we have again here two lines. I'm going to label this one g of x just to be different. Now the line on the left here, okay, notice it has a slope of rise 1, 2, 3, 4, 5, 6, 7, run 1, 2, 3, 4. So the slope is 7 over 4. And the y-intercept is at 4. So it's 7 over 4x plus 4 is the equation of that line. And I'm using this line specifically between the x value of -4 and 0. So between -4 and 0, but not including -4. Okay? I can include a 0 here, or I can include the 0 on the next one. But I'm just going to go ahead and choose to include it here. Okay? So when x is between -4 and 0, inclusive of the 0, not inclusive of the -4, because that's an open circle at the x value of -4. Then my second line is this one right here, which has a slope of down 1, 2, 3, run 1, 2, 3, 4, 5. So the slope is -3 over 5 on that one. And the y-intercept is at the same spot at 4. Now I'm using this line. Notice that there's an arrow on the right. So I'm using it to the right of the x value of 0. So since I already included the x value 0 on this one, I'm not going to include the x value 0 on this one. So when x is greater than 0. Another option would be for me to have not included 0 here and then include it here, and that would also work and be a correct answer. So that's part C. Let's do part B next. So we have here two lines. I'll label this one h of x. This first line has a slope of 1 over 1 and has a y-intercept of 2. So the equation would be 1x plus 2. And I'm using that line to the left of 0, open at 0, so when x is less than 0. The second line is a slope of positive 1 as well, but the y-intercept is at 0. So it's 1x plus 0, which is just x. And I'm using that line to the right of 0 when it's greater than 0 and including 0, because notice it is closed there. So when x is greater than or equal to 0, the y value is going to be x. All right, and then last one, I'll label this one. Running out of letters. Let's redo f of x. Let's reuse f of x. So this one is 3 lines, okay? We have a horizontal line at 1, then a horizontal line at 3, and a horizontal line at 5. So I'm going to use the y value of 1 when x is between 0 and 2, including 0, not including 2. I'm going to use the y value of 3 when x is between 2 and 4, including the 2, not including the 4. And I'm going to use the y value of 5 when x is between 4 and 6, including the 4, not including the 6. All right, next is number 3, where we're graphing the function. So on part A, I need to graph each of these lines separately given the restricted domain. But notice that this first one is not simplified, so I need to simplify it first. So this would be 1/2 x plus 3 over 2. So the y-intercept is actually at 3.5. So if I plot that on the y-axis, it's at 3.5, which would be right here. And then the slope is rise 1 unit, which would be halfway through here, and then run 2 units. So that's going to be the next point. Okay, it's always going to be halfway, rise 1 halfway, and then run 2. So that would be the line. Now, normally I would plot this line, and it would be arrows on both sides, and it would be a solid line in between that. right, completely together like that. However, I'm only using this when x is less than 1. So for the x value of 1 here, all of the part that's on the right of this line, I will actually erase. And I will put a closed circle, oh, actually, it's an open circle at that x value of 1. So I'm going to change this to not have the arrow. And I'm going to erase my closed circle. I almost put a closed circle there because it's less than 1. So it's not including 1. So I will put an open circle at 1 and then the arrow on the left because I am using it all the way to the left of 1, but just not including 1 or to the right of 1. My second one is negative x plus 3. So the y-intercept is 3 and the slope is down 1 to the right 1. Again, normally I would be making this line complete. However, I am not going to do a complete line here because I'm only going to be using this line when x is greater than or equal to 1. So it's going to be from 1 and to the right of 1 only. I would erase any part that is on the left. Now it is greater than or equal to 1, so it will be closed on the x value of 1. And then arrow on the right because it will continue to the right of 1. As long as x is greater than 1, we're going to be using that line. Okay, part C. So notice this is just y equals 1, which is a horizontal line on 1, y equals 2, which is a horizontal line on 2, y equals 3, which is a horizontal line on 3, and y equals 4, which is a horizontal line on 4. But I'm using them over different domains. So I'm using the horizontal line between 0 and 1. Okay, so closed on 0, open on 1. Then I'm using y equals 2 between 1 and 2, closed on 1, open on 2. Then I'm using the y equals 3 from 2 to 3, closed on 2, open on 3. And I'm using the equation y equals 4, horizontal line on 4, from 3 to 4, closed on 3, open on 4. Okie dokie. Next, let's do part B. So the first equation is negative 2x, which means the y-intercept is 0. So we're going to plot the y-intercept at 0, and then the slope is negative 2, down 2, over to the right 1. So again, normally we would have our line would be a full line straight through all of those points. However, notice that we're only using this to the left of 2. So I'm going to have a closed circle at the x value of 2, and then it's going to be only using the left side. So I'm going to put an arrow on the left side, because that is going to go infinitely to the left, a closed circle at the x value of 2, and then the right side of the graph I would actually remove, because I'm only using this line to the left of 2 when x is less than or equal to 2. My next equation is just 4, so that's a horizontal line on 4, and I'm using that between the x values of 2 and 4, open on both sides. So horizontal line on 4, normally I would do a full horizontal line, but this time I'm going to just use it between the x values of 2 and 4, open on both sides. Next, we have our negative x. So slope is negative 1, y-intercept is at 2. So you would start here, and the slope is down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And notice that I'm only using this line when x is exactly equal to 4. So it's literally just that number for 4. Just when x is 4, which negative 4 plus 2 would be negative 2. So it's just that 1 point, just on there. And then the last one, y-intercept is negative 9. 1, 2, 3, 4, 5, 6, 7. Okay, well, it's off of the graph. Either way, I'm going to start at 4 and to the right. So if x is 4, 4 minus 9 would be negative 5. So it's going to be the point 4, negative 5, which would be open because I'm only using it to the right of 4. And then the slope here is 1 over 1. So I will end up using only the right side here when x is greater than 4. All right, and that's that graph. The last graph for part D, we have 3 different lines. My first line is negative 2x plus 0. So the same one as the one that we just did a second ago. Y-intercept at 0, slope is negative 1 over 1. Negative 2 over 1, excuse me. However, I'm using this one between x value negative 3 to x value negative 1. So I would make my line. And then I'm only using that between negative 1 and negative 3. And it's open on both sides. So I would erase everything that's not between negative 3 and negative 1. And is open on both, so open circle on the negative 3 x value, open circle on the negative 1 x value as well. The next line is 3x minus 1, so we have a y-intercept at negative 1, and then the slope is rise 3, run 1. And normally we, again, would have a full line going through all of those. However, notice that the restriction is I'm only using this between negative 1 and 2. Now it is closed on the x value negative 1 and open on the x value of 2. But I would erase the rest of the line. I'm only going to be using the line in between those two x values. So no arrows on either side of those. And then the last one, the equation is negative 1 half x plus 0. So the y-intercept would be at 0, and you're going down 1 to the right 2. And I'm using this to the right of 2 when x is greater than 2. So open circle on 2. And I'm going down 1 to the right. And I will be using that all as long as x is greater than 2, which means that there is going to be an arrow on the right side here because I am going to continue to use this line for any x value that is bigger than 2. All right. Number 4, using the function to the right to give the domain, range, increasing, decreasing, constant, positive, negative, and determine if it's continuous. Well, let's start with continuous. If it's continuous, that means that it would not have any breaks in the graph at all. We have a jump here that is a complete break, and we also have a bunch of holes in the graph. So no, this is not continuous, okay? Next up, let's go ahead and do the domain and range. For the domain, notice that we have points all the way to through the left of negative 1. We have the x value of negative 1, and we have points to the right of negative 1 with an arrow. So you do have arrow on the left to arrow on the right. It will be all real numbers except notice that at x value of 1 is open, and there are no other points that I actually have an x value of 1 for, and I also have an open at 2. So this is going to be from negative infinity till the 1, then union between the 1 and 2 I have points, and then union from 2 to infinity I have points. So I have points from negative infinity to positive infinity, but I don't have any point at x value of 1, and I also don't have any point at the x value of 2. Next, let's go ahead and do the range. So for the range, we want to look at the y values, okay? Now, looking at the points, okay, the y value of the points, all these points here at the bottom have y values all the way from, the bottom is going to be, if I continue the graph, there's going to be a bunch of points there, negative infinity till the y value of 0. And it is an open circle at that 0. So I will have points that have y values from negative infinity all the way up to 0, but not including 0. And then I don't have any points between the y value of 0 and the y value of 2.5. There's nothing there, okay? So there's no points with those y values. The next y value picks up at 2.5 and it is closed, so I will use a square bracket. And then I have all of these points which have y value 3, y value 3.1, y value 3.2, y value 3.3, all the way up to, but not including 3.5. And then we pick back up again right after 3.5, all the way till 4, but not including 4. And then from 4, we pick back up with points all the way up till arrows at the top, infinity. So quite a lot of breaks in the graph. We do have arrow at the bottom, negative infinity, to arrow at the top, positive infinity. However, we have no points which have y values between 0 and 2.5. We have no points that have the y value of 3.5, and we have no points that have the y value of 4. All right, next let's go ahead and do the increasing, decreasing, and constant. We can start with constant. Remember, this is a horizontal line, which there is no part of this graph which is a horizontal line, so there is no constant. Also, there is no decreasing, because decreasing would mean that as you follow the graph from left to right, that the line goes down, okay? And so in this case, that doesn't happen. We see this is positive slope, this is also positive slope. So it is actually just that over the entire domain, the entire graph from negative infinity to 1, and then from 1 to 2, and then from 2 to infinity, it is increasing. The entire domain is increasing for this particular graph. Next up, let's go ahead and do the positive, negative. Positive is what part of the graph is above the x-axis and what part of the graph is below the x-axis. So the part of the graph that is above the x-axis is from the -1 to the to the 1, and then the 1 to the 2, and then the 2 to infinity. This part of the graph right here, okay? So from that -1, and at -1, the y value is +3, so it's inclusive there, till the 1. Then from 1 to 2, we have all those points have a positive y value. And then from the 2 to infinity, all of those points also have a positive y value. The negative y value would be this other part. That is the part of the graph that has negative y values. So that part of the graph is negative infinity to the -1, not including the -1, not only because it's open, but also because the y value at that -1 will be 0, which would not be included anyway, since 0 is neither positive nor negative. Okay, and those are the key features. Number 5, we're answering the same key features, but now we have a different graph. Again, let's start with continuous. Now this one seems like it would be continuous, and it would be, with the exception of, notice that there is a hole there. Okay, so as long as there is a break in the function at all, then it is not continuous. So this is not continuous either. Next, let's go ahead and do the domain and range. Okay, the domain for this one. We do have the first point, which has the x value of -3. And then we have points all the way to the right of -3 till the arrow, infinity. However, this point, which is the x value, of +3, is not included. It's open here, and there are no points with that x value of 3. So it is from -3 till the +3, not included, and then we pick back up right after that 3 to infinity. So it's technically from -3 to infinity, but we're skipping over 3. 3 is not included. Next, let's do the range. Okay, now we're going to focus on the y values for the range. At the bottom, we have an arrow here. So we are going to have points with all of these negative y values. So the range is going to start from -infinity, arrow at the bottom. And then it's going to go all the way up till my highest y value, which is 11. Because after this point right here, with the y value of 11, there are no other points on the graph. That's it. This is the tallest point. So the range will go up to and including 11. Now you might be thinking, well, should we include 7? Because this is open here. So maybe we shouldn't include it. Even though there is not a point with the y value of 7 here, there's tons of points with the y value of 7. There's one right here. So 7 is, a part of the range. There's also a ton of points right here, all with the y value of 7. So even though 7 is not in this point, we do have other points with the y value of 7. So we would include 7 as a part of the range. All right, next let's go ahead and do increasing, decreasing, and constant. Okay, this time we do have a constant piece, which is this horizontal piece right here, which is between 3 and 5. Any point that is connected, we don't say whether that's a part of the increasing, decreasing, or constant piece because it's connected to another piece, okay? So any point that is connected, we are not going to include as a part of that constant because that is the point where you're changing actually from constant to decreasing, is not that it's continuing to be constant, at that point or even past that point. Next, the decreasing. Now there's two parts of this graph that are decreasing, okay? Because if you follow it from left to right, this part goes down, and then if you follow it from left to right, this part also goes down. So since those are two separate pieces, I'm going to write them as two separate intervals. This first one starts at -3 and ends at x value 1. So we're decreasing from -3 to 1. And notice that here I am including -3. Why? Because -3 is an endpoint. So it's not changing from one thing to another thing. It's not connected to another part. So we can go ahead and include it there. And then the other piece starts at x value 5 and ends at arrow on the right, positive infinity. So we would say from 5 to infinity, it is also decreasing. Last part is the increasing. Increasing is the part of the graph that goes up from left to right, which would be this piece right here. That starts at x value 1, ends at x value 3. So between 1 and 3, it is increasing. All right. Last, let's go ahead and determine the positive and negative. So for positive, negative, remember you're looking for what part of the graph has a positive x value, a positive y value and a negative y value. So it seems like this whole entire graph is above the x-axis. But remember, this is going to keep going down, right? So eventually this is going to cross at, that's 11, then the next one would be 12. So it's going to cross here. There's going to be a point at 12. And then to the right of 12, this is actually going to end up being below the x-axis. So the positive part is only the part that would be above, which would stop at that 12. So the positive is from the smallest domain, which has the x value -3, till that x value of 12. And not including 12, because the point at 12 is 12, 0, and 0 is neither positive nor negative. It is neutral. We include the point at -3 because the y value there is positive 11. So the x value -3 has a positive y value, but the x value 12 does not have a positive y value. So that's why we include the -3, but we exclude the 12 for the positive interval. And then the negative interval will be the part that's below the x-axis, which is from that 12 all the way till arrow on the right. So from 12 to infinity, we have our negative interval. All right, number 6, for each of the functions, we're going to go ahead and give the domain and determine is it continuous or not. Okay, well, the domain on part A, notice that I am using part of this line when x is less than or equal to 0, and then I'm using this other line to the right of 0. So I'm using, I have a domain that is negative infinity to positive infinity. Okay, now the question is it continuous? For the continuous part, we want to go ahead and determine at the potential breaking point, which at this case is like I'm using this one line up to 0, but then I switch to a different line at that 0. So the question is, at 0, are they connected? Because if they are connected, then yes, they are continuous. But if they're not connected, they are not continuous. In order for them to be connected, the one equation has to equal the other equation at specifically the x value of 0. So that's the question, is 0 plus 4 equal to 2 times 0 plus 4? Well, 0 plus 4 is 4. 2 times 0 plus 4 would also be 4. So yes, they are equal, they are connected. Yes, this is continuous. Next one, part D. Let's do part D next. So for part D, notice we have here, we're using this one line to the right of -1, including -1. And then we're using this one to the left of -1. So this is also domain of negative infinity to positive infinity. Now, is it continuous? Well, the breaking point here is that we stop with x at the x value of -1. So are they connected at the x value of -1? Let's check. So is 3x minus 1 equal to the -5 at that x value of -1? So I would be plugging in -1, and 3 times -1 is -3, minus 1 is -4. Is -4 equal to -5? No. So this one is going to have the point at -1, -4, and the other one is going to have the point starting at -5. So there's going to be a jump, and no, these are not continuous. So this is discontinuous or not continuous. All right, for part B. This one, I don't even have to try to check are they continuous or not because there is a hole. Okay, remember a hole is a part of the domain that does not exist, that there is a break. Notice that we're using this first equation to the left of -1, and we're using the second equation between -1 and 1, but we're not including -1, and -1 is not included either here or here. So there is a break in the domain here fully, okay? It is negative infinity till -1, and then at -1 there is nothing till positive infinity. Okay, because notice even though 1 is not included here, we are including 1 here. So we are going to have points from -1 all the way to the right to infinity, but it's just going to have a hole. There's going to be no point at all on the x value of -1. So I don't even have to do the work of figuring out are they connected or not, because even if they were to be connected, there would still be an open circle, which means that it would be not continuous or discontinuous. Okay, next part E. Here's another one where, again, based on just like looking at the domain here, we can determine that there is going to be definitely a big break in the graph. We see that we have a line that's going to be used to the left of -1, so from negative infinity till the -1, including the -1, but then we don't have anything from between -1, x value -1 and 2. Like, what do I do with the x value 0? There's nothing there, right? So there's stuff missing completely here in between. The domain I'm only going to use this graph from negative infinity to negative 1, and then from 2 to infinity. There's nothing anywhere else, so this is definitely discontinuous. All right, let's look at part C. So part C is another one where, based on the domain, we can tell this is discontinuous. We're going to use this one equation to the left of negative 1, from negative infinity till that, positive 1, open parenthesis because we're not including 1. And then we have this one that we're using at the value of x value of 3, and then we're using this one to the right of 3. So from 3 to infinity, we do have stuff, but there's nothing between 1 and 3. So this is discontinuous. All right, last one, part F. So notice on part F, we have to the left of negative 3. Then we have between negative 3 and 2. Okay, so we pick right back up after negative 3, perfect, till 2. And then the next one picks up from 2 to infinity. So this domain is negative infinity to positive infinity. So we're going to have to check, is it connected, right? And we're going to have to check at 2 places. First, we have to check at negative 3. Are the first and the second one connected? So is 3x plus 14 equivalent to the 5 at the x value of negative 3? So if I plug in negative 3, I get negative 9 plus 14, which is 5. So it is connected at the x value of negative 3. Now that's perfect. But if that one is connected and then the second one and third line are not connected, it would overall still be not continuous. So I not only have to check the breaking point of negative 3, but I also have to check at the x value of 2. Is the second and the third equation going to be connected? So in other words, is 5 equal to x plus 3 at that x value of 2? Now if I plug in the x value of 2, we can of course get 2 plus 3, which is 5. 5 equals 5. So yes, it is connected both from the first to the second line and the second line to the third line. So this is continuous. Okay. Next, I want us to go ahead and write the absolute value for the graph. Okay, remember that the general form for the absolute value is y equals a times the absolute value of x minus h plus k. So hk is normally our vertex, but remember for the vertex, you will the equation will look like the opposite of h. So in this case, for example, our vertex is 3, 1. So our hk is 3, 1. But in the equation, since the equation is x minus h, we're going to have the equation looking like x minus 3 rather than x plus 3. And then the value of k is 1. Now the a value in front is the slope to the right. So if I look at the slope to the right for this line, it is down 1 to the right 1. So the slope to the right is negative 1. So you could either put like a negative 1 fully there or just like a little negative in front to represent that negative 1 slope to the right. Okay, our next one has our vertex at negative 2, 0. So that's our hk. And the slope to the right is up 1 to the right 2. So the a value would be 1 over 2. So this one would be y equals 1/2 times the absolute value of x plus 2. And then the plus 0, we don't need to put there. All right, the third one here, we have our vertex at 0. Actually, if I look at the graph, it is going up by 5. So 5, 10, 15, this would be 20. And the slope to the right is down 20 to the right 5. So the a value is 4. Negative 4, negative 20 over 5, which is -4. So this equation will be y equals -4 times the absolute value of x plus 0, which we don't have to write the plus 0 part, so the absolute value of x, and then plus 20 on the outside. Okay, last one. So the vertex on this one is -1, 2. So that's our HK. And then the slope to the right is up 1, to the right 1, 2, 3. So the A value is 1/3. So the equation here is y equals 1/3 times the absolute value of x plus 1 plus 2. Okie dokie. Moving on to number 8. So here they want us to go ahead and identify the key features. Identify the max or min, and where it's located, and also the end behavior and the increasing and decreasing. So since I'm going ahead and I'm going to be doing some key features, I'm going to go ahead and make a rough sketch. So on the first one, I need to figure out the vertex and which way it's facing. The A value here is negative, and when you have a negative A value, it is going to be facing down. Now the question is, this is facing down, but what is the vertex? Now remember, the vertex is HK, but in order for you to see what H is, you have to have factored out the coefficient of X. So this is really going to be 2 times X plus 1, which means that the vertex is at -1 for X and 11 for the Y value. So with that now, I can determine, yes, my vertex is actually going to be a maximum, not a minimum. And the maximum is the Y value of that point, which is 11. Also, the end behavior, now that I know that it's facing down, the end behavior is going to be both ends down to -infinity. So as x approaches positive infinity, f of x is going to -infinity. And as x approaches -infinity, f of x is going to -infinity. Both ends, right and left side, are down. Lastly, the increasing and decreasing. So the increasing part would be the left side of the graph, and the decreasing part is going to be the right side. So the increasing part is from -infinity till the x value of the vertex, -1, and the decreasing is the right side, from the -1 to the arrow on the right. Next, part B. Again, we're going to need to make a rough sketch. The A value in front is technically a +1, so it's a positive A value. So this is going to be an upward facing V shape. And our vertex, if I factor out 1/3, divide 1/3, -3 divided by 1/3 will be -9. So my vertex here is at 9, 4. So it is a minimum, since it is an upward facing V shape, at 4. And the end behavior, both ends, are going up to positive infinity. So the right side is going up to positive infinity, and the left side is also going up to positive infinity. Then the increasing and decreasing, well, this time, since it's flipped over, they are, basically the reverse of what we just did on the previous one. The increasing part is actually the right side of this absolute value. So from the 9 to infinity, arrow on the right, it is increasing, and on -infinity, the arrow on the left to the vertex x value 9, it is decreasing. Okay, for part C, notice that our A value here is a negative A value, so this will be facing down. The nice thing is inside of this absolute value, I do not have to factor out any coefficient for x, so automatically I see that the vertex is -6, 0. And I can go in and answer all my key features. So this is going to be a maximum at that y value of the vertex 0. We have our end behavior matches the same end behavior of part A, which is both ends down. So as x approaches positive infinity, on the right side, this goes down to -infinity. And as x approaches -infinity, on the left side, f of x also approaches -infinity. both ends are going down at negative infinity. And then the increasing and decreasing, this one, since it is facing down, the increasing is that left side of the absolute value. So from negative infinity till the x value of the vertex, -6, it's increasing. And from -6 to infinity, it is decreasing, because that's the part that is going down. Last one, part D. Notice that our A value in front is a positive A value. So this is going to be an upward facing V shape. And again, inside of the absolute value, I don't need to factor anything out for x. And there's nothing being added to x, which means that the x of the vertex is at 0. The y value is at -8. So now we can go ahead and answer our key features. In this case, it would be a minimum of -8. The end behavior matches the one for part B since it's upward facing. So the right side goes up to positive infinity, and the left side goes up to positive infinity as well. Both ends go up. Last, increasing, decreasing, which matches the increasing, decreasing, basically, of part B, because it is upward facing. So the right side of the the absolute value V shape is the one that is increasing. So from that x value of the vertex 0 till arrow on the right, infinity is increasing, and from negative infinity to 0, it is decreasing. All right, they want us to go ahead on number 9 and describe the transformation and then graph it. All right, so the transformation here would be, we start on the inside, okay, so that's +2, remember, is opposite, so it's going to be a shift left 2. Then you're multiplying on the outside by a negative and by 3/2. So it is both a reflection over the x-axis and a vertical stretch, because 3/2 is a number bigger than 1, by a factor of 3/2. And then lastly, subtract the 1, which is going to be a vertical shift down 1. Okay, to graph this, we can go ahead and graph the vertex, which would be -2, -1. And then we can use the A value is the slope to the right. So from that vertex, down 3 to the right 2 for the right side, and down 3 to the left 2 for the left side. And that is the graph. Let's do part C next. So on part C, let's do the transformations first. Inside with x, we're subtracting 1/2, which is going to be a shift to the right 1/2. Again, remember, everything with x is the opposite. We're also multiplying by a negative on the outside, which is, again, that reflection over the x-axis, which is why it is a downward-facing V shape. And we're adding 4, which means it'll be a vertical shift up 4, excuse me. Okay, so let's go ahead and graph it. So our vertex is going to be at 1/2, 4. And then our slope is going to be -1. So our slope to the right is down 1 to the right 1. And the slope to the left is down 1 to the left 1. And that's the graph. All right, let's go ahead and do part B next. So we have here again on the inside a shift to the left 2. On the outside, we're multiplying by a negative, which again is going to be another reflection over the x-axis. And we're multiplying 3, which will be a vertical stretch by 3. And we're adding 3, so this is going to be a vertical shift up 3. To graph, let's go ahead and graph our vertex, which is -2, 3. And then our slope to the right is -3. So down 3 to the right 1 for the right side, and down 3 to the left 1 for the left side from that vertex. Perfect. Last one, part D. Okay, now inside of this absolute value, we have two operations. We have multiplying and adding. Normally, we do the proper order is multiply then add. But since it's inside with x, it is the opposite. So I will deal with the adding first, and then I will do the multiplying. So it will be a shift first, and then the multiplication. So the shift, instead of being to the right 6, is also to the left 6. And instead of horizontally multiplying by 3, we multiply by 1/3. So it is a compression by 1/3. And that's it on the inside. On the outside, multiply by 2. So that is a vertical stretch by 2 and down 1 shift. All right, when we do this graph, okay, let's go ahead and find the proper vertex, okay? To define the proper vertex, we do need to go ahead and factor out the 3. Okay, so we're going to take out the 3, which means that this is going to be x plus 2. So the proper vertex here is actually at -2, -1. That's where the vertex is. And when we take out the 3, 2 times 3, if we do the absolute value of 3, it is 3. And 2 times 3 would be 6. So your stretch vertical, so that way you don't only have to think about one of the sides, is by 6. So your slope to the right is 6. Up 6, to the right 1 for the right side. Having trouble making a straight line there. Let me use my line tool. Okay. And then up 6 to the left 1 for the left side. And that is your V shape. All right, for number 10, compare the following absolute value equations and identify which of the following meets the key features described. Okay, the ones that is not shifted horizontally. Well, that's a horizontal shift, so not that one. This one is not horizontal shift because we're not adding or subtracting on the inside with x. And that's the only one. So only b of x is not shifted horizontally. Moving on to part B. Which graph is not stretched or compressed? Now, it's not saying horizontal or vertical. So if we multiply on the y value by anything or multiply the x value by anything, that is going to be a stretch or a compression. So this is going to be a vertical stretch, so that's not our answer. This would be a vertical compression, so that's not our answer. And this would be a horizontal compression because it would be 1/3. So again here, b of x is the only one that is not multiplied at all. So b of x is the only one that is not stretched or compressed at all. Next, part C, the vertex of 2, 1. Well, here the vertex is 2, 1. Here the vertex would be 0, -6. Here our vertex would be -1, 0. And then here, remember, you would have to take out the coefficient of 3. So really the vertex here would be 2/3, 1. So that's a tricky question there if you forgot that part. So the only one that has the vertex of 2, 1 is actually a of x. Okay, next, the graph that is shifted up by 1 unit. Well, shifting up would be on the outside adding 1. So that's a shift up 1. This would actually be a horizontal shift to the left. So that's not a shift up 1. And this is actually shift down 6 for b of x. And a of x has that +1 on the outside as well. So there's two that have a shift up 1. A of x and d of x both are shifting up 1. Okay, next, facing down. Okay, the A value is what determines which way it's facing. If the A value is negative, like it is on this one, it will be facing down. But if the A value is positive, like it is on this one, because the coefficient will be +1, then it is facing up. So this has a negative A value, that's also going to face down. And here, again, the coefficient would be +1, so that's going to be facing up as well. Okay, so the question is which one are facing down? That would be A of x and C of x. Okay, last one, contains the point 5, 10. Now to check that, I have to plug it in. Plug in the x value of 5 and the y value of 10 and see which equation actually matches that point. So let's start with A of x. So is 10 equal to -2 times 5 minus 2 plus 1? Well, 5 minus 2 is 3. The absolute value of 3 is 3. -2 times that 3 plus 1 would be -5. So is -5 equal to 10? No. So A of x does not work. Let's try B of x. Plugging in again, 10 for y and 5 for x. Is the absolute value of 5 minus 6 equal to 10? Well, absolute value of 5 is 5. 5 minus 6 is -1. 10 does not equal -1. So B of x also does not contain that point. Let's move on to C of x. Does 10 equal -3/4 times the absolute value of 5 plus 1? Well, 5 plus 1 is 6. -3/4 times 6 is going to give me some number, but I know it's not 10. So that doesn't work either. Last one, D of x. So is 10 equal to the absolute value of 3 times 5 minus 2 plus 1? Well, 3 times 5 is 15. 15 minus 2 is 13. 13 absolute value is 13. 13 plus 1 is 14. So none of them work, okay? None of these equations contains the point 5,